We continue the problems in matrix multiplication. One more important question here. Matrix A is equal to 1, 2, 3, 3 minus 2, 1, 4, 2, 1. Then show that A cube minus 23A minus 40I equals 0. Okay. See, we want A cube to determine, initially determine A square. Okay, right? A into A. Okay. 1, 2, 3, 3 minus 2, 1, 4, 2, 1. Okay. 1, 2, 3, 3 minus 2, 1, 4, 2, 1. Right? So now, as usual, you can go for multiplication. So in this stage, can I go for direct 1? 1 into 1, 1, plus 2 into 3, 6, plus 3 into 4, 12. Next, first row to second column, 1 into 2, 2, plus 2 into minus 2, minus 4, 3 into 2, 6. First row to third column, yes, 1 into 3, 3, 2 into 1, 2, plus 3 into 1, 3. Next, come to the second row to first column, 3 into 1, 3, minus 2 into 3, minus 6, 1 into 4, 4, 3 into 2, 6. Okay, second row to second column, right? 3 into 2, 6, minus 2 into minus 2, plus 4, 1 into 2, 2. Next, second row to third column, yes, 3 into 3, 9, minus 2 into 1, minus 2, plus 1 into 1, 1. Now come to third row to first column, 4 into 1, 4, 2 into 3, 6, 1 into 4, 4. Next, third row to second column, 4 into 2, 8, plus 2 into minus 2, minus 4, 1 into 2, 2. Third row to third column, 4 into 3, 12, 2 into 1, 2, 1 into 1, 1. So it is finally 12, 18, correct? 12 plus 6, so 18 plus 1, it is 19. I think 8 minus 4, it is 4. 5 plus 3, 8. Next, 7 minus 6, 1. 6 plus 4, 10 plus 2, it is 12. 10 minus 2, it is 8. Okay. Next, 14. Here it is 4 plus 2, 6. 14 plus 1, it is 15. So now, once you determine this, okay, now you go for calculating a cube. A cube can be written as what you know, a square into a. A square into a, yes, 19, 4, 8, already you determined, right? 1, 12, 8, 14, 6, 15. Now that multiplied by A, matrix A, 1, 2, 3, 3, minus 2, 1, 4, 2, 1. Okay. Now once again, as usual, go for multiplication. First row to first column, 19 ones are 19, plus 4 into 3, 12, plus 8 into 4, 32. First row to second column, 19 twos are 38, 4 into minus 2, 8, 8 twos are 16. First row to third column, yes, 19 threes are 57, 4 ones are 4, 8 ones are 8. Okay. Now, second row to first column, 1 ones are 1, 12 threes are 36, 8 fours are 32. Next, 1 twos are 2, 12 into minus 2, minus 24, 8 into 2, 16. Okay, now come to last one, 1 into 3, 3, plus 12 into 1, 12, plus 8 into 1, 8. Next, third row to first column, 1 into 14, 14, 6 3s are 18, 15 4s are 60. Next, 14 2s are 28, 6 into minus 2, minus 12, 15 2s are 30. Last one, 14 3s are 42. Okay, 14 3s are 42, 6 into 1 6 plus 15 ones are 15. So what final answer on a cube? See here now, 19 plus 32 plus 12. How much you see? 19 plus 12, 21, 31 plus 32, it is 63. Okay. 38 minus 8, 30, it is 46. 12, okay, 60, 12, 8 plus 4, 12, 12 plus 57, 59 plus 10, that is 69. 32, 36, 68, 69, right? 2 minus 20, I think 16 plus 8, 18, 18 minus this, minus 6. Okay, 12 plus 8, 20 plus 3, how much it is? 23. Next to 14 plus 18, 60 plus 18, it is 78, 78, 82, 92, I think, right? Next to 30 plus minus 12, how much you see it is now? 30 minus 12, 18, or 28 minus 12 you can take. 16, 16 that is what? 46. 28 minus 12, 26, that is 16. Okay. Here how much you see? 48 plus 15. 15 plus 6, 21, 21 that is equal to 63. So now we take this LHS of the equation now, left hand side of the equation, AQ minus 23A minus 40I. Now replace. What is this? 63, 46, 69. Okay. Then 69 minus 6, 23. Then 92, 46, 63, okay, minus 23 into matrix A. Replace the matrix A. 1, 2, 3, 3 minus 2, 1, 4, 2, 1 minus 40 into identity 1, 0, 0, 0, 1, 0, 0, 0, 1. So now 63, 46, 69, 69 minus 6, 23, 92, 46, 63, okay, minus 23 ones are multiply, okay, scalar, 23 twos are, 23 threes are, 23 threes are, 23 minus 2, minus, okay, 23, then 23 fours are 92, 23 twos are 46, 23 ones are 23 minus 40, 0, 0, 0, 40, 0, 0, 0, 40. Okay. So now go for this. Right. Now 63 minus 23, how much it is? 40. First we will take these two. 46 minus 46, 0, 0. 69, 0, minus 6, making plus 40, I think. 23 minus 23, 0. 0, 46, 0. 63 minus 23, it is 40. Now, minus 40, 0, 0, 0, 40, 0, 0, 0, 40. Yes, which it goes to null matrix, you know. Yeah. So, you know the null matrix, okay. So, therefore, it is equal to 0. So, this is a, once again remember, it is a 5-mark question in the examination, it is totally very important and repetitive question in the examination. So this is what on matrix multiplication. Secondly, transpose of a matrix. So what do you mean by transpose of a matrix? See now, let us take an example. We take matrix A is equal to 1, 2, minus 3, 4, 5, 6. Now, what is the order of this matrix? You see, 2 rows, 3 columns, 2 cross 3. Okay. Now, we interchange the rows and columns of the matrix A. Okay. Or interchanging the rows and columns. Now, if I interchange, see, first row become your first column. Second row become your second column. Is it right now? See, this is what. So now this matrix we refer as transpose of the matrix. Okay. Transpose of the matrix is denoted by A dash. Right. the matrix obtained by, okay, the matrix obtained by interchanging the rows and columns. The matrix obtained by interchanging the rows and columns of the matrix is called transpose of the matrix. See, if A is any matrix, okay, the transpose of the matrix is denoted by what you know, A dash or A transpose. Just observe now, the order of the matrix A is cross 3. Once you transpose that, then A dash order is given by what you know, 3 cross 2. So that means generally, if A is a matrix of the order m cross n, then the transpose is having the order n cross n. Okay, if the matrix A order is m cross n, then the transpose order is given by what you know, n cross m. So now the next we shifted to properties of the transpose of the matrix. Okay, what are the properties of the transpose of the matrix, right? See, the first property here is given by A plus or minus B whole dash is always be equal to A dash plus or minus B dash. Okay, similarly A into B whole dash is always be equal to B dash into A dash. This is very important property. We refer as reversal law. This one, AB whole dash is equal to B dash A dash, right? The next one, K into A whole dash is always be equal to K into A dash. Okay, K into A whole dash. The fourth one, A transpose whole transpose A dash whole dash is always be equal to what you know, A. So these are the 4 properties of the transpose of the matrix. Okay, 4 properties, very important properties in the transpose of the matrix, right? So now we'll see some of the problems based on the transpose of the matrix, right? If matrix A is minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. Matrix B, minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. Okay. So now what is this? Verify. Okay. A plus B whole dash is equal to A transpose plus B transpose. First one. Similarly, A minus B whole dash is equal to A dash minus B dash. First we will go with the first one. See, for this we require matrix A plus matrix B. First problem. Okay. I want to determine A plus B. Okay. What is this? See, minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1 plus matrix B. Minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. Yes. Now you add these two. Minus 1, minus 4, minus 5, 2 plus 1, 3, 3 minus 5 is minus 2, right? 5 plus 1, 6, 7 plus 2, 9, 9 plus 0. Minus 2 plus 1, minus 1, 1 plus 3, 4, 1 plus 1 is 2. Now what we require? We require transpose, right? So that can I determine A plus B whole dash. Now interchange. Interchange minus 5, 3, minus 2, 6, 9, 9, okay? Minus 1, 4, 2. Is it right now? Minus 1, 4, 2, last one. Okay. So now, this is, call this as equation 1. A plus B whole dash. Next, what I require is A transpose. What is your A transpose? Directly can write minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. Next, I am writing B transpose. Okay. So minus 4, 1, minus 5, 1, 0, 1, 3, 1. Now adding these two, A transpose plus B transpose, you add these two, yes. Minus 1, minus 4, how much? Minus 5. 5 plus 1, 6, minus 2 plus 1, minus 1. 2 plus 1, 3, 7 plus 2, 9, 1 plus 3, 4. 3 minus 5, 3 minus 5 minus 2, 9 plus 0, 1 plus 1, it is 2. Now, this is what the second one. Now, comparing the equations 1 and 2, I think both the matrices are same, right? So, conclude the result now from the equations 1 and 2. A plus B whole dash is always be equal to what you know, A transpose plus B transpose. In the similar way, you can try yourself this one. First, what you have to determine A minus B, then you take the transpose. Then A dash minus B dash, that should be equal, because this should be definitely satisfied, because this is the property of the transpose of the matrix. Okay. So the second one, try yourself. A dash minus 2, 3, 1, 2 and B equals minus 1, 0, 1, 2. Okay. Then what he says, find A plus 2B whole dash. A plus 2B whole dash. First of all, determine A plus 2B itself, initial stage itself. See this, A minus 2, 3, 1, 2 plus 2 into minus 1, 0, 1, 2. See, that is given by minus 2, 3, 1, 2 plus minus 2. See, you have to multiply 2 into minus 1, 2 into 0, 0, 2 into 1, 2, 2 into 2, 4. How much you see? Minus 2, how much? Minus 4, 3 plus 0, 1 plus 2, 3, 2 plus 4, it is 6. Now, for this is what you know, A plus 2B, right? Now, we require A plus 2B whole dash, taking the transpose. Yes, minus 4, 3, 3, 6, right? So this is what A plus B, A plus 2B whole dash is, right? Small mistake here. One moment. Sorry. See, what is given is A transpose is given. I'm solving directly in the initial stage. Now A plus 2B, that is transpose is given, we want to determine A. Minus 2, 3, 1, 2 plus 2 into minus 1, 0, 1, 2. This is minus 2, 1, 3, 2 plus 2 into minus 1, minus 2, 0, 2, 4. Okay. Now, minus 4, 1, 5, 6, right? So now what I am determining, you see, A plus 2B whole dash, that is minus 4, 1, 5, 6. Let's find the answer for this. Next one, verify AB whole dash is equal to B dash A dash. Very important question from the examination point of view. Okay. Sometimes this is a 5-mark question it is. Okay. So B is given by 1, 5, 7. See, AB whole dash. First, what I am determining is, yesterday I told you, I solved one problem based on this. 1 minus 4, 3 multiplied by 1, 5, 7. Right. So now, first you have to multiply these two. See, in the last class, yesterday's class, how to multiply. First of all, you find out the order here. See, it is 3 cross 1, it is 1 cross 3, columns is equal to rows, multiplication is possible, right? So now, the process of multiplication, row versus column. Yes, 1 into 1, 1, there is no second element, that's all. First row to second, 1 into 5, 5, first row to third, it is 1 into 7, 7. Minus 4 into 1, minus 4. Minus 4 into 5, minus 20. 4 into 7, 28. Right? 3 into 1, 3. 5 3s are 15. 7 3s are is 21. So now here I am taking the transpose for this matrix. Okay? AB whole dash. See, that is 1, 5, 7, minus 4, minus 20, minus 28. Okay. Next one, 3, 15, 21. Right? See, this is AB whole dash. First part. Next, what I require? B transpose into A transpose. What is for B transpose? 1, 5, 7 into multiplied by A transpose. Right? Just once again, just observe the order here. 3 cross 1. It is 1 cross 3. Definitely it is possible. Go with this. Yes. 1 into 1, 1. 1 into minus 4, minus 4. 1 into 3, 3. Next, second row. It is 5. 5 into 1, 5. 5 into minus 4, minus 20. And 5 into 3, 15. Next, third row. 7 into 1, 7. 7 4s are 28 with minus. 7 3s are, it is 21. All this is equation 2. So from compare the two equations. Okay. 1 minus 4, 3, 5 minus 20, 15, 7 minus 28, 21. Okay. So from equations of 1 and 2, can I write A into B whole dash is equal to B dash into A dash. Okay. This is an important question. The same. Verify. AB whole dash is equal to B dash A dash. Okay. In the same second problem, this A is equal to 0, 1, 2, and B is equal to 1, 5, 7. Okay. As usual procedure, I will go with calculating A into B first. 0, 1, 2 multiplied by 1, 5, 7. Regular multiplication. Yes, 0 into 1, 0, 0 into 5, 0, 0 into 7, 0. Next, 1 into 1, 1, 1 into 5, 5, 1 into 7, 7, 2 into 1, 2, 2 into 5, 10, 14. Okay, now taking the transpose here, AB whole dash is equal to 0, 0, 0, 1, 5, 7, okay, 2, 10, 14, all this is equation 1. The next part we will go with finding B dash into A dash. So now B dash into A dash, B transpose now, 1, 5, 7 multiplied by 0, 1, 2, yes, as usual you can go. Okay. 1 into 0, 0, correct? 1 into 1, 1. Next to 1 into 2, 2. Next to 5 into 0, 0. 5 into 1, 5. 5 into 2, 10. 7 into 0, 0. 7 into 1, 7. 7 2 is 15. So now once again we conclude the result from this equations of 1 and 2. Okay. A into B whole transpose is equal to B transpose into A transpose, right? So this is a very important concepts on transpose of the matrix. Okay, problems from the transpose of the matrix. The next one we shifted to, the next part is symmetric and skew symmetric matrices. Symmetric matrix. See, what do you mean by a symmetric matrix? See, we'll take an example here. Okay, 2, 1, 1, 2. So you can take 3 also. Okay, no problem. What is the transpose here? Interchanging the rows. First row 2, 1. First row I am writing first column. Second row I am writing second column. Just observe what happens here. A transpose is equal to A. Is it right? So then such a matrix we called as what symmetric matrix. Okay. See, that is a square matrix, right? A square matrix is said to be symmetric, right? A square matrix is said to be symmetric matrix, right? If A transpose is equal to A, then the matrix is called symmetric matrix. One more question may be define symmetric matrix. A square matrix A is said to be symmetric matrix if A transpose is equal to what A. For example, I'll go with one more example on the third order now. A is equal to, say here, 2, 3, 1, 3, 4, 5, 1, 5, 6. Okay, this is A. What is your A transpose? Interchange. Yes, 2, 3, 1, 3, 4, 5, 1, 5, 6. Just observe now. 2, 3, 1, 3, 4, 5. So can I say A transpose is equal to what A? How to write? Just analyze the symmetric matrix now. What happens? I think in a square matrix, this is whatever principal diagonal, right? See, just you see the elements above and below the principal diagonal, 3, 1, 5, 3, 1, 5. So that means elements above the principal diagonal are the reflection of the elements which are below. See, 3, 3, corresponding element, 1, 1, 5, 5. See, this is the idea behind writing this symmetric matrix now. So this is symmetric. Now the next one is given by skew symmetric matrix. Okay, skew symmetric matrix. How can I say it is a skew symmetric matrix now? See, once again I will go with an example. If A is equal to 0, 2, minus 2, 0. So what is the transpose? A transpose is equal to 0, 2, minus 2, 0. Okay. See, A transpose, in this you can take negative sign outside. Okay. You take this negative sign outside from this matrix. Then 0, this is plus 2, here minus 2 is 0. Just to analyze A transpose, can I say this matrix is A here? See, A transpose is equal to what minus A. So that is a square matrix. Okay. A square matrix is said to be, a square matrix is said to be skew symmetric. Okay, a square matrix is said to be skew symmetric matrix. Okay, if A transpose is equal to minus A, very important. If A transpose is equal to minus A, then the matrix is said to be skew symmetric. I'll write the third order, one more matrix for this skew symmetric. Just to analyze here. Okay. minus 3, 0, 6. 4, minus 6, 0. Now you go for this A transpose here. What happens? You see, A transpose, yes, 0, 3, minus 4, yes, minus 3, 0, 6. Okay. 4, minus 6, 0. So that is A transpose is equal to now it is negative sign 0, 3, minus 4, minus 3, 0, 6. Okay, 4, minus 6, 0. I think this is the matrix A now. Yes, A transpose is equal to 0, 3, minus 4, minus 3, 0, 6. Okay, 4, minus 6. A transpose is equal to what minus A. Therefore, this matrix is what? Skew symmetric matrix. So now I think one thing you analyze here, what happens in a skew symmetric matrix. Just to analyze, see, in a skew symmetric matrix, the principal diagonal element, observe in both the cases of second order as well as in the third order, in the diagonal elements are always equal to 0. That means in a skew symmetric matrix, the principal diagonal elements are always equal to 0. And see the other element 3 minus 3 minus 4 plus 4 plus 6 minus 6. The diagonal elements are 0. The elements above the principal diagonal, just to see how to write this skew symmetric matrix. This is an important concept. 3 minus 4 6 minus 3 4 minus 6. Elements above the principal diagonal are the reflection of the elements which are below the principal diagonal with opposite sign. Okay, with opposite sign. See, plus 3 minus 3 minus 4 plus 4 plus 6 minus 6. This is how we can write the symmetric and skew symmetric matrices. Okay, so point to be noted down here is, okay, yes, what is that point to be noted down? Skew symmetric matrix, principal diagonal elements are always be equal to 0. Principal diagonal elements are always be equal to 0. So now regarding this symmetric and skew symmetric matrices, okay, we have two theorems. Okay, first one is given by theorem number 1. You can take. See, for any square matrix, A, okay, A plus A dash is always symmetric. Okay, A plus A dash is symmetric, and A minus A dash, okay, A minus A dash is always what matrix? Skew symmetric matrix. Okay, any matrix, any square matrix you can take. A plus A dash is always symmetric matrix. And for any matrix, you add the transpose of the matrix. That matrix is always which matrix? Symmetric matrix. Similarly, for any matrix you always subtract with the transpose, then the matrix is always which matrix? It is a skew symmetric matrix. Okay, skew symmetric matrix. This is what your first theorem on this. Okay, now if you want, we can prove this also. So now let you can take A be a square matrix. Okay, A be a square matrix. See, we have to prove that A plus A dash is what matrix? It is symmetric matrix. We are proving in case 1 and case 2. Case 1 you can take that I am taking B is equal to A plus A dash. Here what I am going to prove now we have to prove that matrix B is which matrix? It is symmetric matrix. Okay. Now taking the transpose on both sides. Okay. Taking the transpose on both sides, what happens? B dash is equal to A plus A dash whole dash. B dash is equal to, here A plus A dash whole dash, can I use the property on the transpose? Which property? A plus B whole dash is equal to A dash plus B dash. So what happens? It is A dash plus A dash whole dash. Once again A dash plus A dash whole dash. Once again this is the property on the symmetry transpose. A dash whole dash is equal to what? A. So now A dash plus A, it is always be A plus A dash, commutative. So therefore B dash is equal to A plus A dash is B. So that means the matrix B is a symmetric matrix. Okay. So it is a symmetric matrix. So that's the first part of the problem. Now we take the second part here. So that is given by, let us take C is equal to, second part, A minus A dash. Okay. Here what you have to prove? You have to prove that matrix C is which matrix it is? Symmetric, right? Matrix C is, you have to prove that matrix C is symmetric. Once again take the transpose. Okay. Taking the transpose on both sides, right? So that is C dash is equal to A minus A dash whole dash. C dash, here we are using the property A minus B whole dash is equal to A dash minus A dash, right? So A minus A dash whole dash, A dash minus A transpose whole transpose. Or you see A dash, A transpose, whole transpose is A. C dash minus sign I am taking outside from this. A minus A dash. So C dash is equal to A minus A dash is what? C. So C transpose is equal to minus C. Therefore, the matrix C is what you know. It is a skew symmetric matrix. Okay. It is a skew symmetric matrix. So the first theorem here is for any square matrix A plus A dash is always symmetric. A minus A dash is always you know. It is a skew symmetric matrix. This is one time maybe an examination corner question also. This is how the simplest proof. The second theorem, this is only the statement, okay. Theorem number 2 in this. Any square matrix, okay, can be written for any square matrix A, okay, or any square matrix, right? For any square matrix A can be written as A is equal to half into A plus A dash plus half into A minus A dash. This problem is very important on this property. Any square matrix can be written as a sum of, remember it is sum of symmetric and skew symmetric. See, this A is equal to A plus A dash. According to this property, A plus A dash is always which part? It is symmetric part, plus A minus A dash, it is always which part? It is skew symmetric part. Is it right now? A square matrix, theorem number 2 is, any square matrix can be written in the format of sum of, okay, sum of, first part is symmetric, second part is what you know, skew symmetric. That is what A plus A dash is a symmetric part, A minus A dash is a skew symmetric part. Any square matrix can be written in the form of sum of symmetric and skew symmetric. So that is a very important question from the examination point of view also. It's a 3-mark question in the examination. Express the matrix okay, as a symmetric and skew symmetric matrix. Express the following matrices as sum of symmetric and skew symmetric. Okay. First one I'll take 3, 5, 1, minus 1. Okay. So now let us go with taking the matrix A as 3, 5, 1, minus 1. What I require as you know A plus A dash. Now what is the transpose? A transpose you write 3, 5, 1, minus 1. Right? Determine A plus A dash. Okay. So directly can I add you know 3 plus 3, right? 6. 5 plus 1, 6. 1 plus 5, 6, minus 1, minus 1, minus 2, right. This is A plus A dash. Similarly, determine A minus A dash, subtraction also. Yes, it is. Subtract 3 minus 3, 0. 5 minus 1, 4. 1 minus 5, minus 4. Minus 1 plus 1, it is 0. Just you know that, okay. How can I write, you know? Half into A plus A dash plus half into A minus A dash. So now A is equal to half into, yes, go for A plus A dash, 6 minus 2 plus half into A minus A dash, 0, 4, minus 4, 0. Just I am replacing, okay. Yes, now multiply 3 and it is to 3s, right? We are multiplying 1 by 2 with this matrix. It is minus 1 plus 0, 2, minus 2, 0. So now, this is what the matrix. See, if you add, you can get the original matrix. 3 plus 0, 3 plus 2, 5, 3 minus 2, 1, minus 1 plus 0. But you cannot add and you can write it. You can express this in this way only. See, this part is always symmetric part. You just observe this. This is a diagonal element, and this is always a skew symmetric. You just observe this once again. Principal diagonal elements are 0. Other element, see, +2, -2. Reflection of the element with opposite sign. So this is what the problem. So you can keep the answer like this only. The first part is always representing symmetric part. The second part is always representing skew symmetric part. Okay. I'll go on to the one more problem on this, right? So that is the second one. 1, 5, -1, 2. Let us take this matrix A, right? Now what about A transpose here? A transpose 1, 5, -1, 2. So now A plus A transpose. See, that is 1, 5, -1, 2. Just can I write directly for this? Yes, it is. Adding these two matrices, 1 plus 1, 2, 5 minus 1, 4, minus 1 plus 5, 4, 2 plus 2, 4. Similarly, determine for A minus A dash here. Yes, 1 minus 1, 0. See, 5 minus 7 minus 1 plus 6. Minus 1 minus 5 minus 6. 2 minus 2 become 0. So now once again we know that a square matrix A is equal to half into A plus A dash plus half into A minus A dash. Yes, half into, find out A plus A dash here, you know already, 2, 4, 4, 4 plus half into A minus A dash, 0, 6 minus 6, 0. 1, 2, 2, 2. Okay, plus 0, 3, minus 3, 0. So this is what you can add. You can get the original matrix 1, 5, minus 1, 2 plus 0, it is 2. So this is the symmetric part, right? This is the skew symmetric part. This is how we can. Usually in the examination this question appears only for this second order. Now I will go for third order also. We will write one problem based on the third order matrix also. 3 minus 1 minus 2 minus 2 1 minus 4 minus 5. Let us take this A. Okay. Now A dash is equal to 3 minus 1 minus 2 minus 2 1 minus 4 minus 5 2. So now as usual we can find out the A plus A dash. Okay. What is A plus A dash here? See, corresponding element 3 plus 3. I am writing directly. 3 minus 2 1 minus 1 minus 4 minus 5 minus 2 plus 3 1 minus 2 minus 2 minus 4 1 minus 5 minus 4 minus 4 minus 1 minus 5 minus 5 plus 1 minus 4 2 plus 2 4. Okay. Now A minus A dash. I am subtracting these two matrices. Okay. See, 3 minus 3 0. 3 plus 2 5, right? Minus 1 plus 4 3. Minus 2 minus 3 minus 5. Minus 2 plus 2 0. 1 plus 5 6. Next one minus 4. Okay. Minus 4 plus 1 minus 3 minus 5 minus 1 minus 6 2 minus 2 is 0, right? So now we can use our regular formula. We know that any square matrix A is what you know, half into A plus A dash plus half into A minus A dash. Half into A plus A dash, go for replacing 6 1 minus 5 1 minus 4 minus 4 minus 5 minus 4 4 plus, okay, half into A minus A dash 0 5 3 minus 5 0 6 minus 3 minus 6 0. Yes. Go for multiplication. 3 1 by 2 minus 5 by 2. See, 1 by 2 minus 2 minus 2 minus 5 by 2 minus 2 plus 0 5 by 2 3 by 2. Yes, minus 5 by 2 0 3 minus 3 by 2 minus 3 0. Okay, this is symmetric, this is skew symmetric. This is how we can express the matrix as a symmetric and skew symmetric matrix.